Hello everyone, welcome to the Skill Talk, your learning partner for maintenance and the reliability. I hope you guys like our thermography series, the basic one. So I believe that most of you have the benefit from that. And from today's session, we will be starting our next series, that is the vibration analysis series. And in today's video, we will be learning about what exactly the vibration is, and we will understand its different types, and we will be seeing some real life examples, and we'll be finding out that why vibration analysis is such a powerful tool in the industry. So welcome guys to the intro of the vibration analysis. So first we will be discussing about that what is vibration. So vibration simply means the back and forth movement of an object around its normal position. So you can say that it is the physical motion that we feel or measure when a part moves due to energy inside the system. So since we know that every rotating machine, whether it is a motor, it's a pump, it's a fan, it's a compressor, it's a gearbox, right? So it vibrates due to some extent, right? So when the vibration is smooth and controlled, so what we will say that our machine is healthy. But when it becomes rough, irregular or intense, maybe there can be any issue or there can be some problem that machine is facing. So overall the pattern of the vibration of that entire machine will change, right? So the problems can be, it can be even a minor problem or a major problem, like let's say like any motor or the gearbox is facing the loose bolts issue, or any bent shaft is there, or any bearing is damaged, right? Or any gear is wear in the gearbox. So there can be multiple reasons for that. So by observing these changes, what we can tell a lot about what's happening inside the machine without even opening it, right? Now these vibrations are of multiple kinds, multiple types of vibrations are there. So now to understand the vibration clearly, let's do one thing. Let's break into the three main categories of this vibration. So in our day-to-day life or in our industries, you will be seeing almost three types of vibrations. One is the known as the free vibration, and another one is the forced vibration, and the third one will be the random vibration. So these are basically the basic forms of motion that happens inside any machine, okay? And each type of this vibration tells us the different kind of story. So now we will be discussing these three vibrations in detail, so that you can have the clear idea about this, that how these vibrations are different from each other. So let's first discuss about the free vibration. So in this type of vibration, what happens when a system is disturbed, let's say, and then left to move on its own, okay, without any continuous or the external force. To make it more clear, let's take one example. Imagine a spring with a weight attached, okay? So if you pull it down and release, what will happen? The spring will move up and down freely until it slowly comes to rest, right? So this type of vibration is known as the free vibration. Now in real machine, we rarely see such kind of a pure free vibration. Why? Because most of the machines are always being driven by some kind of a external force, or you can say the motor, or you can say the drive, right? We often use this concept of free vibration during the design time of this machine. Why? Because this helps us to understand that how a component naturally moves or resonate. So every structure or a part is having a natural frequency, so the rate at which it prefers to vibrate freely. So in that, during the design phase only, we are using mostly this free vibration, okay? Now the next type of vibration is the forced vibration, okay? So this is what we normally see in the working machines. So here what happened, the vibration is caused by an external force that keeps acting continuously on the system. So let's take few examples in this. Let's say a motor with an unbalanced rotor. So what will happen, that this uneven mass will keep pushing the motor up and down with each and every rotation. In same way, you can take multiple more examples. Let's say a pump with a bent shaft, or a fan with the excess dust, okay? Or you can say the gearbox with the damaged bearing. So lots of other examples we can have for the forced vibration. So in the forced vibration, whatever, the system keeps vibrating as long as the force is present, okay? Or you can say the defect is present, okay? So if the frequency of this force happens to match the system natural frequency, then something is known as the resonance that can occur, and that can create a huge vibration amplitude and even damage the machine. So this resonance part we will be discussing in later on in these videos, because it's something, you know, more details or more technicality needed to understand this resonance topic, right? So in vibration analysis, our goal is to find and remove these continuous external forces. That these external forces can be unbalanced, can be misalignment due to the damaged bearings, okay, bent shafts. So before they can lead to any failure, or they can create any impact on that entire machine. So let's move to the third one, that is the random vibration. So it's, you can say, the most unpredictable type of vibration this is. Because why? Because random vibration doesn't follow any kind of a fixed pattern. It's caused by a multiple forces that is acting together at a irregular intervals, so you can't predict the next moment exactly. So right, so it's just like the turbulence you feel in the plane, okay, or the vibration on a running vehicle. You can say you are going through a car and, you know, the bumpy road is coming, and sometimes the road is okay, sometimes road is bumpy. So, you know, you don't have any kind of a particular pattern or the frequency for this, right? So in industries, normally these random vibrations often appear in the large or the complex machines. You will be seeing such kind of random vibrations. So let's say the machines like turbines or crushers, or you can say the big gearboxes, right? So where many source of energies are you can say that interact together, you know. So when we analyze these kind of random vibrations, we don't look for single frequencies or the single or fixed peaks that we are doing in the forced vibration, right? So instead here what we do, we will be studying its overall energy distribution, or you can say the statistics behavior, like how strong and how often the vibration changes over the time, right? Overall, it will help us to identify the reasons for the instability, or you can say the high noise or the looseness in this entire system. So these are the three type of vibrations that we normally see acting in our machines. So now let's discuss that why this vibration analysis is so important. So now, since we know that the basic types and, you know, basic types of vibration, so let's talk about that why vibration analysis is so important. Because it's simple, you know why? Because vibration tells us the true story, right? So almost every mechanical fault that, or you can say the electrical fault, that gives us some kind of a vibration signal or some kind of a vibration pattern before it fails. So by measuring it continuously and analyzing those signals, we can detect the problem well before, and also we can plan the maintenance and prevent the sudden breakdowns. So it's just like you know, the health checkup of your machine. So you normally, if we take an human example, so normally we don't wait for getting a heart attack to visit the doctors, right? So what we do, we will be tracking those symptoms early. So and you have always heard that, okay, whenever there is any kind of a discussion that, okay, we have to implement the condition monitoring program to our plant or something, so always the condition monitoring means vibration is the first name that you will be hearing from the people, right? That condition, like most of the people will think that, okay, condition monitoring means mostly the 90-95% is vibration analysis. Why it is? Because among all the condition monitoring techniques, let's say thermography, ultrasound, or oil analysis, or you know, the current signature analysis, MCSA, so vibration analysis is often the first choice. There are some reasons for this, because this technique is highly sensitive for the, even there is a small change or small you know, a small kind of deviation in the machine behavior, so immediately you will be having the you can detect them. And second is the non-intrusive. Why? Because we don't have to open and stop the machine to you know, to note the changes that is happening in the machine. And the third, you can say it's applicable to almost all kind of rotating machines, right? Even you can say from small motor to the large turbines. And also it will give you a clear mechanical as well as the electrical, in some of the electrical insights also. Okay, mechanical insights we can have almost, you can say 90%, but electrical also, few of the electrical faults also, it will give us give us early indication. So it's just not the surface level information, or it gives us the entire detail of or you can say the entire depth of that entire machine, that what is going on inside that machine. So that's why when industry think of predictive maintenance, always vibration analysis is always a part of the strategy. Okay, so let's summarize this video. So what we learn in this video is that we have discussed that what is vibration, that is a simple motion, back and forth motion. And also we have discussed the main three types of vibration, that is the free vibration, forced vibration, and the random vibration. And also we have understand that how these will help us to interrupt the machine behavior. And the last we have discussed that the why vibration analysis is considered as the backbone, or you can say it's considered as a very important part of the condition monitoring program. So thank you guys for being with us. In the next video we will be discussing the next topic of this vibration series. And till then, thank you for watching Skill Talk, and be with us. Please share and like if you find that we are adding some kind of a value to you guys. And thank you.